So, Paul, thanks a lot for joining this call. Thanks a lot for helping me in the presentation today. And for those that don't know Paul, he's a researcher in sports science, as I am, and there's many people that work in with high density electromyography, actually. And he has been the developer of the graphical user interface. So if you can interact with the openhdemg functions by pressing buttons, so using something that is like software, it's thanks to him that had the idea to create the user interface and then developed it and is constantly maintaining the user interface. And Paul is working in Switzerland, in Basel, and is mainly investigating techniques for automatic ultrasonography imaging analysis. These techniques are really cool, at least in my opinion, as they use machine learning to automatically detect muscle borders and therefore the size of the muscle, but also the pennation angle of the muscle and so on. In a process that is usually very slow and time demanding, and he is trying to automate this type of analysis, and so far he has been quite successful with some publications in the field. And now he is also looking at electromyography analysis with us. So thanks, Paul. I leave you the stage. You can introduce the today's lesson.
Thanks for the introduction, mate. Yeah, today we are gonna talk about functions, classes, and object-oriented programming. And I'm gonna start by sharing the screen. And what object-oriented programming is in Python is basically centered around functions and classes and objects. And basically you can imagine objects like real-world objects, for example, like a bottle. And a bottle has certain, let's say, attributes or certain effects or certain things that you can do with it. For example, you can screw open the lid, and maybe the lid does also fit on another bottle. Or you can drink from it, or you can pour the water on a plant and the plant grows. So there's a lot of things which you can do with the bottle. And these are, let's say, specific to the bottle, but they can also be applied to other things. Now, as I said, we're going to deal with functions and classes. And classes let you basically define structures and behaviors of objects. And they encapsulate, let's say, the attributes of an object. For example, the color of the bottle, or the material of the bottle, or how much water is in the bottle. And objects can be instances of classes. By this, it's basically meant that we have, let's keep the bottle example here, we have a bottle and we have a class that is describing the bottle, and we can combine them so we know which color the bottle has, how much volume is in the bottle, and so on and so forth. But we can also use this class to apply it to a new bottle, second bottle that has, for example, a different material. You all have the script available, and we're just going to start with it because then we will see what functions do. Now, we have different kinds of functions, let's say. Functions can either have a return value or not, and we will see in a second what this is. Because functions that don't have a return value are called procedures. So basically they do something for us, which we tell them to do, but we cannot reuse what comes out of it. Functions that have a return value, we can work with them further, and we can use the return value in order to go on with our code. These two import statements here on the top, they're not in your code, they're just here in mine, and we don't need them at the moment, but I will go on with them nonetheless. So I hope you're already hooked up in your terminal. activated the environment with all of the steps that you've seen the last couple of times on how to do this, and you can just follow me. So what you can see here is an already defined function. So we start a function using the def command, followed by the name of the function. And we can give it any name. The name doesn't matter, but it should be descriptive. So always try to name your function in a way that describes what it does. There are different ways of naming the function, and there are different, let's say, naming conventions. If I remember correctly, Giacomo, we use the snake case continuously during the code, if I'm correct?
Yeah, everything, all the functions are defined in lower cases. We use
Exactly.
upper cases only in classes.
Exactly. So lower cases and separate words are separated by an underscore. So for example, like this, read name. There are other options, which is Pascal case, for example, which you would do like this, but we only use this in classes. It doesn't change anything with the code or so. It's just another thing that is good practice and helps you quickly see what the function does. Now, you see that here's a comment, and I commented it for you to see because it says docstrings in functions are good practice. Docstrings, we also haven't heard of them yet in this tutorial series. The docstrings are basically large comments. And docstrings describe what a function does in more detail. So a docstring starts with a statement that describes the function and what it does. So this function, greet name, in our case, greet a person with a hello message using a procedure. Here, why a procedure? Well, this function, as you can see, does not have a return statement. If it would have a return statement, it would be written below here, but we'll get to that in a second. Also, the function has parameters. In our case, that's name, the name of a person to greet. Well, what is a parameter? Well, you have used functions last time in the data structure tutorial series with Giacomo. For example, you calculated the mean of something using NumPy. And what you put into this NumPy function, into the mean function, was basically the parameter you gave it. So we can have functions that have a parameter. In our case, the parameter is name. Imagine it like this. You have a juice maker machine, and you can do the juice maker machine whatever it does, but you need something in there in order for the juice to come out. So when you want different juice, for example, if you want orange juice, then you would need an orange. If you want apple juice, you would need an apple. And this apple, or let's say kind of fruit, in a way is your parameter that you put into the function and something comes out. You can also use functions without parameters, but it wouldn't make much sense. But I'll show you this in a second. Now, back to the docstring. Parameters, we define them here as name, and then there's a colon and an str. It looks a bit weird, but basically what this is indicating is the type of the parameter. So here we would indicate that name is a string. Then a short description of the string parameter, and then what it returns. And in our case, it returns none, it returns nothing, because we don't have a return statement. So this docstring, and you will see them throughout all of the library if you use the code, and also in the GUI, it's very descriptive of what the function does. And there are also different docstring styles. So for us, we use a NumPy docstring style. But there are also Google docstring styles and so on and so forth. It's not important in the end, it's just a matter of consistency. What these docstring do is actually if you hover over the function, you can see something is displayed there. And that's a very cool feature of VS Code because when you hover on a function, the docstring will be displayed. So you see the function, what it returns, the parameters, and the description. So it's really informative. how do we activate the function? Well, we do it the same when we are in the terminal, in VS Code, right? We can just define it. Now we see that nothing happens, but if we scroll through the terminal, we can see define greet name, then the comment, the doc string, and then we can type something else again. The code that is actually in our function and belongs to our function, you can see that it's not in the same line as the define statement. It's indented. And indents are really important because indents are what makes Python say all of the code is in the function. When there's no indent, like below here and here, we basically tell Python that we're not in the function anymore. We're now writing different code. And this is an important thing to remember, that one should always indent the code when it's written in the function, much like for an if statement, right? You write an if statement, then there's a colon, you indent your code that is just executed if the if statement is true or false. Same principle here. Now, the code in here basically just prints hello, then as a formatted string the name, and then welcome to our openhdemg class. As you can see, I have written the function below here. Initially, it was the function greet, now it's greet name, so I would need to change it, right? Greet name. VS Code also has a cool autocomplete feature here. Same for here. Now, what would happen if we do this? Well, you can see the name here and here. Basically, we specify Alice as our name, as our input parameter, or sticking to the example, as our input fruit, and then running the function. So if we execute it, we can see in the terminal, hello Alice, welcome to our openhdemg Python class. So what we did is basically put a string in the function as the name parameter, and it uses the name and prints it out. It's not that hard. If we change the input parameter, it will do exactly the same. So in the end, it doesn't matter what we put here as a string. We can also put Giacomo, and it will still do the same. What this parameter here is called doesn't matter as well. We can, for example, put fruit in here. If we would run it like this, and we can see what happens now, it's still not working because I didn't define the function. Define the function again, run it, we'll have a type error. This is because we got an unexpected keyword argument. Because here we set fruit as our keyword, as our input parameter, and here we specified name, which is incompatible. So if we define fruit here, and run it, we get another error, a name error. And this is because here name is written, but nowhere else is name. If we write fruit, define it again, run it, and it's fine. So you can see what the parameter name is does not matter at all, as long as we keep it consistent. That's basically the takeaway. For the guys that are live with me, are you with me so far? Is everything clear? Or anything that we need to go through again?
That's fine, it works.
All right. Okay. Now, you have seen that this function, it just does something, but it doesn't have a return statement, which in some ways is fine and useful. In most cases, it isn't. Because now whenever we call this function independently, if we have a fruit or a name or whatever, we can't really use it. We just see it printed out in the terminal. The advantage of a return value is that we can reuse the function and we can actually assign variables with the function. And I've written another function here for you to see what I mean specifically. Now we have another function defined. It's called addNumbers. As you can see, we have now two input parameters. And these input parameters are always separated by a comma. So in the end, we can have limitless amount of input parameters as long as we can separate them with a comma. A is an integer, as specified here, B is an integer. And now it returns an integer. So we can see here is a return statement. And it returns the sum of A and B. Now what happens and why is this actually important? So when we define the function, we also need to define A and B. And now you can see something that hasn't been here before. It's written result equals addNumbers. Again, A equals A, B equals B. We can use the result. Now nothing happens, right? Before we saw something gets printed, and now nothing happens because we assigned the return value of this function to result. But if we print the result now, we can see that it does just that. 4 as our A plus 5 as our B equals 9. Again, we can change these as we like. It will do something different. What is also nice is that we can do something like this now. Which will return 15. So you can see, even though we didn't specify any function, we can work with the value that it gave us before, which is really nice because it shortens our code and we can reuse what we already have. This is just the difference between the return statement functions, so the function functions, or the procedure functions. A thing that is very important and that we need to stress, because we try to keep it or kept it consistent throughout the library in the GUI, is that we call the functions using the parameter names. What I mean by this is the writing convention as is shown here. So whenever we call a function, we define the parameter that we want to use. It would also work if I do just this. Right, it will do exactly the same. 7 plus 5 equals 12. The problem here is that we always need to be consistent in the order of the variables. Meaning, if I do this, so remember, A equals 7, B equals 5. We now have still 7 plus 5 equals 12, which means it took our B as A and our A as B, which at this point might not seem as a big problem because we only have two variables. So I think we can remember which is first and which is second. But if, let's say, we have 10 or 12 parameters, we don't always like to remember in which order they come. And what is here very nice is we can also do this. And then you can see it's right again. And in this way, we don't need to remember which parameter is where, but also we can mix them around in the function, which makes it a lot easier for us. Another thing is that I wanted you to tell is actually we can specify the type of the parameters inside the function as well. So you know of the different types of the variables, such as strings or integers. And you've seen that we can define them in the docstrings, which is fine. But what we can also do is define them in the function definition itself, which means if we write A colon int and B colon int, it will not change anything in the function whatsoever, but we can just see what these parameters are intended to be very easily, which makes it a lot easier for us. Now, a last thing that we can do is actually also specify default values. And you will see this a lot in the library, where several parameters have default values that can be changed, but don't have to be changed. What is important here is that the parameters with the default values always have to be at the end. So here we just specify the type. This one has to be in the front. Parameters with default values have to be in the end. What this does, if we define it again, is that we don't need an A. We can delete our A. I'll keep it here because this one refers directly to the A, but take a look at the result now. So we have the B, we have the result. We will use the function. And we still have the A. But you can see it's 14, which doesn't make any sense, right? 7 plus 5 should be 12. Now it's 14. Why is that? Because the default for our A is 9. We didn't define our A here when we defined the result. So it just grabs 9, which means we have our default and we see 14. It's handy at some point. It can be used very well if you know what a parameter should be, but also want to let your users have the option of changing it. And it can also, again, save you time and code if you anyway use the same parameter over and over again. Another thing that is sometimes written in the library is basically this, which is not important at all, but it just tells you in the function definition what it should return. So in this case, it's an integer because we have two integers here as a sum, and it will return an integer. Just as your information, but this is nothing life-threatening whatsoever. Now, I have most of what I said, I have written down here for you. So why function should be called with argument names or keyword arguments. It's clarity, flexibility, and default values, as we've just seen. Now, I want to start with a short hands-on for the functions. And the hands-on, you can see that here, and you can try it. I guess the next 5 minutes should be enough. And you should write a function that computes the mean of an input array of integers. So, as we've seen before, we define, and also in the rest of the code, we define a function by starting with the def statement. And then, because I have a very smart computer, it already indicates and knows what I'm going to do. This is actually a very nice VS Code extension, which is called Cody. It's based on a large language model and analyzes previous code and then tries to basically think ahead for you. So we're going to use it without the docstrings, compute me. And we also don't need this. And we don't need the type specification. So basically, we say we have our function compute mean and an input array. In the end, we could also just call it numbers or whatever we like. We can then go ahead with the code, and let's say our mean equals, and now we have different options. One is the one that you see suggested here, so we can use libraries that are already available. This would be the easiest way. We could also do it ourselves with the few things that are integrated already in Python. So what we could do is we could use the sum of numbers and then divide it by the length. Because if we have a list of numbers or an array, right, we can just sum it up and divide it by the length, which will give us the mean. So we will use the suggestions here. Then what we need, as is written in the descriptions, it says return. And then what should we return? Well, what is description of what we did plus the mean. So again, we can use what is suggested here by my very fine helper Cody, and just use the suggestions. Now we just need to define our input parameters, which would be, let's say, a list, or we can call it numbers or numbers list, for example. And again, you have suggested a list. We can also use a NumPy array. It doesn't matter in the end. I will use the suggestion for simplicity. And then we have the mean value, which is our function, compute mean, and our input parameter numbers list. Now, what we need to do to define the function is just run it, run the numbers list. And now again, as we've seen before, nothing happens. But we can use print the mean value, and then we can see the mean of the numbers is 3, which is fine. Here, not as written before, we already have the string, the mean of the numbers is 3, because we defined it here in the return statement. This is the reason why it is already returned here and specified in our mean value. This is, well, it's sometimes okay, but it's not very ideal, because in this case, if we have a formatted string and we want to further work on the mean value, it's okay for some cases, but in most cases, we just want it to be a number or a tuple or an array or whatever, something with which we can work. I hope that was clear to everybody, and I also hope that you managed to do this on yourself. Was that all right, or was it too tricky?
It was all right.
All right, nice. Okay, then we can continue. Another thing that you will see in the library are args and keyword arguments written in function as parameter definitions, like here. Args and keyword args. Basically, we have two options here. So as I've said before, we can have, in theory, an unlimited number of input parameters for our functions. At some point, it just gets tedious to define them all, and the code will be endless. This is why we use args or KW args. I've again written the description for you here and also in the sample code. So args is basically used to send non-keyworded variable length of arguments. So an indefinite number of arguments can be sent in this parameter here without keywords. What a keyword is basically the thing that you saw before. So when we define the a parameter, we've written a equals a, or name equals whatever, right? This is our keyword, and we don't need this here. Whereas for keyword args, we basically, as you can see here, keyworded arguments. So we can define or we can input an indefinite number of keyworded arguments. And how this looks like is described here. So we have, again, the function, it's called process data. Our input parameter is args, and the parameter is a tuple, as you can see here, and it's a variable length argument. We can define the function again. What it does is basically it prints what it's processing and then prints the item within our input tuple. And we can call it like this, so it's very simple. We can call process data. And you can see that just processing data items is 1, it's openhdemg, EMG, it's true, it's 3.14. So what this means is basically you can put in there integers, strings, booleans, or floats, whatever you wish. Just put it in there. If I add something like 35 or apple, we can just do it again, and you can see 35 and apple. Here again, if I write 42, for example, it matters where I place the stuff because it's non-keyworded. So if I put the 42 here, it will appear at the beginning. It's pretty simple. It just needs to be set once, just that you know what happens in the library. Now, keyword arguments. Basically, we have a function now that's called configure processor, and it has parameters, keyword, which is a dictionary. And it's a dictionary of keywords or keyword arguments with settings for our processor. If we define it real quick, you can see again, it prints the processor settings. And then what it does is for key and value in the KW items, print the key and the value. And now you can see we have configure processor here and 2 parameters that we inputted. So filter type, the filter type that we want to use, in this case, a high pass, and our threshold. When we run it, we can see configure processor settings, filter type, and threshold. It's here. If I add something different, for example, the sampling rate, right? Configure processor, sampling rate is here. Now, you've seen them both separately, but we can also combine them, args and kwargs. So sometimes you see it like this. And then we can just copy the same thing here. And let's say 1, 2, 3, and hello. Redefine the function, configure processor, and you will see our args here, 1, 2, 3, 4, hello, and filtered, and again, RKW args. So this is just a way of giving flexibility to the user with your function that you have. And also, if you don't necessarily need to specify how many input parameters are used for the function. For example, if we take the mean that we've seen before as an example, you can calculate the mean now in an indefinite number from an indefinite number of lists, for example, or just numbers, integers, whatever. So it allows you quite some flexibility in your code. But that's also all what it does. And I just wanted to show it to you because it is in the library at some points. Did you get that, or are there some unclarities here?
I think we can say that arguments always need to precede the keyword arguments because they are only defined by position.
Yes, that is a good point, which is also why I've written it here. So we can try it. See what happens. You can see already it doesn't work. Just it doesn't even let me define the function because of the thing that Giacomo said. This is exactly the reason why we always define it beforehand. Okay. Now, since there are no more questions, we will continue to our second hands-on part. Try to write a function that multiplies an unknown list of input parameters, in this case, integers. and return the value in a formatted string describing what it is. Again, try to use the args function. You can also do it without it, but it's just easier. And forget the docstrings, as we've agreed on before, but just remember, whenever you try to write a function that is not included here in this tutorial, write docstrings. Then, if there are no complications or questions, we can just jump to the solution. And we can start the same as before. So define our function. And again, I have a very smart computer. So we have our function, and let's call it multiply numbers. And we will use the args command. Go ahead and define it. And we will not use the docstrings as we've agreed on before. And now we need to do something peculiar at the moment, which is this. So basically, we need to define a starting point for our function. And this is just so that we have because we're multiplying, we need a starting point. And the starting point can't be 0, it can't be none, it needs to be something. So because we make our lives a bit easier, we define this as 1, and then loop through our args, through our arguments. And this is seen here. So for number in args, you've seen for loops before, product, and then this weird thing here, which just means multiply by. So it takes product. In the initial stage, it is 1. And then it takes product times number. This is all that we need to do. And again, we can just simply return the state. So what this function does is it multiplies the numbers that we are specifying in args and returns the end product. For visualization, I will print the product for you to see what I mean by defining the starting point. If we use the function now, again, it has a return value, so we can assign the function to the variable basically. So let's say product. Let's do value equals, and then our multiply numbers, and we'll use the suggestion. Again, same input as before. We have multiply numbers 1, 2, 3, 4, 5. If we run it, here. The product of the numbers is 120. So sorry about that. I didn't know why the issues kept happening here, but we will continue on like this now. It's very similar to what we did before, right? We have an args argument here, which lets us define an unlimited amount of numbers that we can use. If we go like this, save it again, run the whole thing over. So we get another error because I specified the wrong thing. Run it, and we can see that the product is now different. So this is a rather easy way of using the args argument, but it is very versatile, as you can see at some points in the library, and it is very often used to let you do exactly this. So inputting several numbers of which you don't know at the beginning what the length is. Again, I have written the explanation down here in which you can see what args and kw args does and why it is used. Now, after that very short detour with the errors, we will come to classes. Classes are in a way like meta functions. And what you can think of with classes is basically if you have a bookshelf, let's say, and normally in a bookshelf there are books, and these books describe different things. They tell you a story, they make you smarter, whatever. And you can take out the books of the functions and the books of the bookshelf, and you can read it, you can let it play around, you can give it to somebody else for reading, and you can put it back in. But these are all, let's say, attributes of the bookshelf. They belong to your bookshelf, so you hope that people that you lend the book will give it back to you. But anybody basically that can read can benefit from the book. So if a certain object, let's say a human, has the attribute that he or she can read, he can make use of the book. And a similar thing happens with classes. So with classes, we can define objects, as I've said in the beginning, and we can put instances to them. And instances are, in a way, the books that I just said, in my example with the bookshelf. Now let's go through the class that I've defined here in detail. A class in Python is always denoted or defined by the class statement, and then followed by the name of the class. So here the class is called signify. As you can see, it's now a different naming convention that we've used with functions. It's capital letters followed by capital letters, just to distinguish between functions and classes more easily. Again, the class has a docstring, a short description, and then an attribute section. The attributes of a class are basically, when we go back to the initial example of the bottle, let's say the volume that fits in the bottle. In this case, or in our case, it's a dictionary that configures contains the configuration settings for a processor. Now you can see something that's a bit more weird. This is called an initialization function, and it is used to start the class, to initialize our class. It always have this weird self parameter here, and then like a normal function, another parameter. And it works just like a normal function. You can call it, for example, like the numpy.mean function that you've already used. And you need to input certain parameters, the ones that are specified here. Here it's also described. The init function has a parameter which is called config.dict, and it's a dictionary containing various configuration settings. What is needed in the init function is that we assign our attributes, the parameters that are in here, to our class. And what we can do this by is by using the self parameter. So in a way, everything that has a self dot in front of it is associated with our class and can be used throughout the whole class. Now, before we've seen when we use the functions that the parameters that are in the functions are function specific. So when we go back here, for example, product is function specific. We cannot get this product from the outside. We cannot actually access it. It's just inside the function. In classes, this is not necessarily the case, because if we define our variable like this, we can access it throughout different functions of the class. We can even access it from outside the class. So it's a huge benefit in order for us to make work a bit easier. Then after the init function, which is necessary, there are several other functions that we can put in the class. Virtually, we can put as much in there as we want, but at some point it gets a little messy. And the different functions in the classes, they usually do different things. Each does a separate part. And in the end, they can all work together for one class, or we can just make a class and use it for something else. And then all of these methods, as they are called, can be used on a different object. Now let's go through the functions. So for example, this function is called display info, and it prints the configuration settings from a dictionary. It loops through the dictionary and prints the key and the value. The next function is update config, which here you can see has a kwargs argument and prints config dict and the kwargs and then loops through it all. Now, it might seem as a bit much, but it's a very easy concept, and maybe it's better understood if we go through how to actually use a class. And this is done by specifying the input parameter. Remember, it was config dict, as we said in the initialization function. And in our case, let's say it's an EMG. It's a dictionary that has certain keys and value pairs, for example, the source, the file name, and a sampling frequency. For those of you who have used the GUI, you might know those as they are displayed when you load a file in the GUI. Also the motor unit number, but yeah, let's stick to those. When we run it, we can just actually scroll up a bit. We can see that we need to assign the class here to an object. And the object is in this case EMG. And what we then continue is work with this object, not with the class, not with signal file that we initialized here, but with the class. And we can then access the methods in the class, as is displayed here, from the outside by just working with EMG. And this is the same thing that you do when you use functions from other packages, and you will see this a bunch of times throughout the library. So for example, when you use NumPy to calculate the mean, you usually write np.mean, and this dot is nothing else than what is done here. We can run it. It's now a bit harder to see, but basically it did that. Because in the display info, it prints the type of the value, and then it prints the key and the value pair. So here we can see it's a class is string for demuse because it's a string. Same for the file name, and for the sampling frequency, it's an integer. Now, here are the explanations of class attributes and methods, so the things that I've just said before. But we can also use the second method that we defined in the class, which is update config. And the update config, as we remember, lets us update our dictionary with an unlimited amount of keyword arguments. So here, for example, we have the file name, which we can change. We added one, which is where we changed the source as well. And we added the number of motor units. And we can see this if we scroll a bit down. Here, we again have the updated configuration. The file name updated to the new one, the source updated to a TB, the number of motor units added, and this is now the dictionary, which is in the EMG, so in the EMG that we defined here in the function, in the config. Now, as you remember, right at the beginning, we have also defined our EMG date. This was the starting point for us. And here, we can also print the EMG date. And it will leave this one unaffected. Because we've overwritten it now and we've run the whole script, I'm not sure if it does, but usually if you initiate a class on a dictionary argument, like here, and then modify this dictionary argument in the class, so our self.config.dict, the outside argument or the outside variable here will not be changed, right? So we can do whatever we want with it in the class. If we define it properly in the code, like so, it doesn't matter if we access this one again. If we access this one, of course, then it's changed. This is just something to keep in mind. And it's also always good practice, as you will see in the library a bunch of times, to make deep copies of this stuff, just to make sure that your original files are not being changed in the end. So this is classes. And I know it's a bit of a tricky concept, and it needs a bit of time to understand it. But if there are no questions now at the moment, we can go to the last exercise and do that one. You can try to define a class that is initialized by 2 parameters, sampling frequency and time, and you can try to include 2 methods. One, basically to generate a random signal on frequency and time, and another to plot the signal. So this is now more advanced stuff, and I will just copy the solution in a couple of minutes because it would take too long otherwise. But it's just, if you want to try it, you can do this based on the lessons that you already had with Giacomo. You can just go back there, search for the code, and then you can, as I've written down here, use the function done by random to generate the random signal, and how to plot it also Giacomo showed you last time. So you can go ahead and try it. Otherwise, if you have questions now, just feel free to ask. We define a new class, which in this case is called EMG file. And it is a class that represents an EMG file and has the functionality to generate a plot of a EMG-like signal. We have different attributes, such as sampling frequency and time, and 2 methods, which is generate signal and plot signal. We define it like this. In the init statement, we have our 2 parameters, fsum and time. But what we see here is the 3rd parameter that is not defined in our init statement. Why? Well, there are 2 things that you can do, depending on what your philosophy is in the end. You can either define all of the attributes that you use throughout the class in the init statement, even without them being input parameters, which is just good practice, and Python will complain if you're not doing it, or you can just define them on the go. You will see both versions in the library. It depends a bit on the structure of the code. But we do not need to define this one as long as we don't write it as a parameter in the init function. Now, second function was generate the signal, which basically just uses NumPy's random module to generate a random signal that has the sample frequency times the time in 1 dimension. And then we plot it simply using matplotlib, as you've already done before, I guess last time, with defining a figure. This one here is not strictly necessary. It just plots it to the time domain. Otherwise, it would just be the frequency. But it's not necessary. And then we can plot it. When we run it, you can see that we have the signal. And here you can see the signal that is created with the sampling frequency over the time. again, it's a very basic example of what can be done with function. And you will find a lot more functionalities throughout the library. So I would say, as it already was a bit much, that this concludes the tutorial today. We've already reached like almost 1.5 hours. You can find some additional material on functions and classes when following the links here. And also Giacomo will, or me will upload the solutions to the GitHub as has been done recently. So to those that were online, I guess it was awesome having you here, and I hope you could take something from it. If you have any questions now, just feel free to ask.
Thanks a lot for Paul for the presentation. As I always think classes are the worst part of Python, are the most difficult part, not to use, but to understand.
Yes.
So it's okay if people don't get them from the beginning or the first times.
Yes, it took me a long time. It took me a long time to get it. Functions are okay, but classes then are very much complex.
This is also why also in the library we use classes rarely, only if strictly necessary, because we wanted to make the code as simple as possible, and for new users it's a nightmare to go through the classes.
Yes, except for the GUI.
Well, but then it's the only way to do it, so we didn't have
Exactly.
any other choice.
Exactly. All right.
If we don't have any other question, I think we can close. Paul, thanks a lot for this presentation. Thanks a lot again for all the work you have done in the openhdemg project, and that you will continue to do, of course.
I will, for sure. All right.
Okay, and we see again for the next classes that will be more oriented to EMG analysis. So with today we finish the basics of Python, and from the next time we start doing some analysis that are actually useful for our work. But the basics are fundamental to become autonomous.